So hello everyone. We are reviewing the PR number 31622, which is the this PR. So this PR is based on PSBTs, which is like nothing but a partially signed Bitcoin transactions. So PSBT introduced very new features which we haven't before. Especially when we want to create or sign multi-sig wallets when we have more than two participants. So it provides us some and we'll see. So I think I will give you a little overview, like what is a PSBT, a high-level overview or intuition behind PSBTs. Not very much in detail because we need to review the code as well. So let's suppose there are n number of participants here, n number of participants, and let's say starting from 1 to n. Let's say we and these participants created a wallet, a multi-sig wallet, where we need n by n signatures. Means all of these participants needs to sign a single transaction. We need all of them signature to validate a transaction. So if you try to sign all of these, so suppose if you create a transaction here and you want to spend this transaction, and you need all of the signatures of all of the participants here. Suppose these represents the signature. You need n signatures here. So what you will do in a old-fashioned way, like you go to the person one and ask them to sign the transaction, and then go for the two, three, four, five up to n. So this is very complicated and time-consuming process. So then we came up with the idea of PSBTs, known as partially signed transactions. So what we do in this, we we just create a PSBT, and then suppose this is the PSBT. It's same like a transaction, but it only consists of some basic information like a specific input and a specific output. Then after creating this single PSBT, and one more thing is anyone can create this PSBT, not just first or second participant here. Anyone can create this PSBT, but they need to reference to the UTXO, the a valid UTXO here in the input. So after creating this PSBT, I will write if I can my okay. After creating this PSBT, what we'll do, we'll send this PSBT to all of the participants at single time. Suppose instead of sending this one by one, we create this and send the copy of this to all of the participants in a single time. So after this, what will happen? The participant one, let's suppose, receive this PSBT. They will they will just sign the PSBT and put their signature in this PSBT. The one thing we need to notice here, the participant 1, 2 up to n receive the copies of this PSBT, not this exact same PSBT. Means there is no reference call here. We are copying the PSBT between the participants. Suppose participant 1 has their own copy of PSBT, participant 2 has their own copy of PSBT, but This is not the actual PSBT we created, but the information is same in all of these PSBTs as the original PSBT. So this will sign in their signature and fill the information here. Like it's validated. Yeah, I want to sign this information based on inputs and outputs. Same for the participant 2 to up to participant n. When these all of all of the participants signs their PSBTs, what we'll do, we tell them to get we'll tell them to send us this signed copy of PSBTs here. Suppose we received all the PSBTs. One for this is for participant 2 to n. So these PSBTs. I am referencing this here. After we get the copies, these copies contains the valid signature for the for a single participant. So what we'll do, there is a RBC command, which is a combine PSBTs. So what that command do? This will combine these all PSBTs into one and build a single PSBT, which consists of every signatures of these participants here and the same output and input as this initial PSBT we created. Okay, so you can see where this PSBT concept is helpful for us. Instead of sending uh, the whole transaction one by one, we can send the transaction parallelly to each participant. That's the power of PSBTs in Bitcoin. And then after signing each transactions individually, we can combine them using a combined PSBT RPC in Bitcoin, and this will create a single PSBT, which is a valid transaction. Now you can broadcast this transaction in the Bitcoin network. This is a simple Bitcoin transaction consisting of n by n multi-sig wallet or n by n wallet. So you can simply broadcast this. So that's the high level overview of what our PSBT is. And let's go to the what this PR says. Here just simply says like before this PR we have sig hash values. I think you all guys know what is sig hash. So the sig hash is just nothing will append after every signature uh, to uh, to commit to the entire transaction or a specific input or output. So there are many types of sig hash we use, like anyone can pay or uh, a single sig hash which only commits to the one input of the transaction, and anyone can all sig hash all just commits to the entire transaction mean after you apply the sig hash all, no one can edit the transaction later on, no one can add the inputs or any outputs later on. So if he wants to add anything, the transaction commitment simply fails, and yeah, he can't do this. So in the previous PSBT's behavior, like they the PSBT doesn't know about any sig hash, whether it's default or all or any other sig hash. So it's completely ignores this condition of sig hash. But after this PR introduced, the changes we'll look into the transactions input, whether the transactions consist of a sig hash value of default or all or any other value. If it's any other value, we will check if the value uh, in the transactions or provided by the CLI by the user is same or not. If it's not same, we'll just discard the transaction. Or if it's different than default or all, but a user just simply validly signs the signature with that signature, we just uh, we just use the that sighash value to pass to tell the other users, yeah, like this user uh, used any other sighash than a default or all. What I'm trying to saying is, like for example, if participant one use a sighash value which is not all or default, then what the Bitcoin core will do after this PR change when the participant two uh, receives this transaction, they know like yeah, uh, the sighash is not default or all. मतलब they have idea like this is not the default behavior. They can act upon this. They can do whatever he needs to do. But he have some idea about what is. So let's see the changes. For this change, we are introducing some error cases. For example, there is a one case incomplete and okay. There are two cases here, and we are just adding these cases in types. And here we are introducing these optional field rather than a int field. As you can see, before we have a single int, but we have optional. Why it's optional? While this sighash type is optional here because the sighash type is not int. This is in the form of error, or this is in the form of like here PSBT error, unsupported, or incomplete, or okay. Like this can be any of these, not just a int. That's why we are setting this as optional. Means if a user don't provide a valid integer sighash type, we will default assign this with any of default or all. So same here. The previous line is just checking whether we can sign a PSBT input or not. It's returning a bool, but this time we are checking if this sign PSBT input returns an assertion type error like okay, like you can see here. The error is of type okay, means our sign PSBT input function successfully signed one of the inputs in our PSBTs. That's why it's returning an error of type okay. Well, it's not an error, it's just an abbreviation. So that's not an error. That's a new type of return message we have built. So nothing else here. I will also show you what this sign input function do later on. So, but uh, the changes are very like big in several files. All the small details are changed. Some are repetitive. So we'll see. Same here, as I explained. Uh, we are checking whether this is not equals to the state okay, while in the above code we aren't doing this because sign PSBT input doesn't returning any of these similar errors or assertions. And yeah, the one more thing is uh, we need we need to carefully look is 1 here. As you can see, we are hard coding the one before these changes. This one is corresponds to the sighash type 1, which is equals to the uh, anyone can, like not anyone, which is equals to the default behavior of sighash, which means we are we are committing to the entire transaction. But in this change, we are not hard coding the one. We can also leave it as a null operator or anything, because we'll I will see, like we'll see why we are just writing this as a null, because we'll assigning this later on in our code. So for now, we can't just say it is one. It is it is a default value here, like the transaction commits to the signature commits to the entire transaction. That's not the case here. And same here, you can see here the signed PSBT input returns a bool, but now this returns a PSBT error type. So this is the newly type we have introduced in the signed PSBT input function. So we'll see same here as optional sighash type we are introducing rather than int, because this is not our hard-coded behavior for now. Same here, instead of true, we are saying this return code is true for now. Instead of true, this PSBT error okay code is true. And for false, we'll also see like what's the code for false. Yeah, that's the code for false. That's the PSBT error missing inputs. And that's the new version of saying false. That's just a new way of saying false. You can write anything you want, whether it is the missing inputs or anything. It's just a programming thing. And that's the same. So that's a few lines of change here, in which what we are, yeah, look. So if sighash is not given to us, if sighash is not given to us, well, what we're doing here, we are trying to look in the UTXO, and in UTXO we are referring in the script pub key, and we are checking if it's the payroot input, which is a type of payroot or taproot, sorry, pay to taproot. So whether it's a taproot input or not, we are just checking. If it is, we are assigning with the sighash default type. If it's not, we are assigning with the sighash all type. So we are just checking whether a sighash is provided or not. If it's not, we are checking to the inputs. In inputs, we are referring to the script pub key, and in this we are checking if it's a taproot address or not. So if it's a taproot address, we are hard coding the sighash type to sighash default. Otherwise, if it's not a taproot address, we are simply just assigning it to the sighash type. So here we are just checking if in the score we are checking if we have already given a sighash type in our input. For example, there is a transaction in which there are multiple inputs and outputs. In one of the input, we are already given a sighash type. If it is given, means it if it's true, then we are checking if this type is like it's if it's not equals to the type we have assigned above, like if it's not If it's not default or all, then we'll just return the error like mismatch. The main reason for this error is simply two things. First is we are specifying like our input consists of a certain type of sighash type, and we are passing through CMD like this is our different sighash type. When these two values aren't matching, we are just returning a error here. So same here, like we are referring to the UTXO for the inputs. We are referring to the script in the UTXO, and if it's a taproot transaction or not a taproot transaction, if it's a taproot input, then we and if its signature is not is equals to default, and uh, if it's not default, then we are hard coding this with this sig hash here. And if it's not a taproot transaction, then this condition holds true here, which means we are comparing here if sighash it's not equals to default or sighash all, then we'll just hard coding uh, uh, for this sighash also here. Okay. After this, as you can see, after these line of codes, we are initializing the sighash type to something, not sighash type to the sighash to something. So after these line of codes, our sighash should contain some value. So that's the asset for here. Means if this sighash contains any value, then yeah, if it's true, then asset doesn't do anything here. We just simply move forward in the code. Uh, in this line of code, we are just passing the reference to the sighash, not just the original or copy of the sighash. Why we want to do? Because our sighash must contain some value, and if it has some value, if it is not null, then this function always works uh, consistently, and it's just a reliable function if it's hold true, because if you try to dereference dereference a null pointer, it's a mess. You can't do that. Or if you want to dereference a dangling pointer in your code, this just end up being an error. So that's why we are passing a reference to the sighash, not just a original sighash, because we are sure that our sighash contains any value here. Because if it is contains some value, then dereferencing the sighash doesn't do anything wrong, doesn't give you anything unexpected behavior. So that's why we are trying to dereference the sighash. Same here. No, the meaning of false is just changed. It is incomplete or any other error code we just defined above. Same here. If the complete is the true, we are returning with the error of true, and if it's not, we are returning with the error of incomplete, meaning meaning that that's not our final input for the signing. We need more PSBTs. So that's the code. So this code just simply checks for if we want to remove any non-witness UTXOs from our code. For example, suppose we have all the inputs, which is of type SageWit, means they contain. they contain some witness data rather than value in outside the witness field. They have some witness field. Then we don't want any UTXOs which is not of type witness. So we want to remove all of the UTXO which is not witness. But this condition only holds true when when we have all the output of all the inputs which is of type SageWit. So if we have any of the inputs which is a non-SageWit, then we can't perform this operation here. So just this code loops through the PSBT inputs, as you can see here, and this will check whether the witness program whether it's null or not, and according to this, this will just clear the two drop where it's defined, yeah, a vector. This is a vector of unsigned integer. So we are clearing this vector here if it's null, and if the witness version is equals to 0, then also we are breaking the loop and initializing this to drop uh, to clear its contents. Afterwards, uh, like uh, here, and the second conditions is if a sighash type at the rate at operator and 80. This is the binary form of sighash anyone can pay. That's hex, not a binary, sorry, hexadecimal form of sighash anyone can pay. So if it's true, then we also clear this. After running these line of code, we are sure that we don't need to remove any uh, non-witness UTXO set from our UTXOs. That means, as you can see, this loop here, this runs. Uh, this is dependent on to drop a variable, a vector here. As you can see, this vector initialized here, and we are just clearing this vector time to time by comparing the if condition. As you can see in all of the above code, we are just clearing the vector. So we make sure nothing inside this, like no element exists inside this. So after this, we are iterating uh, to this vector, but at the end, if this vector contains no value, then this loop doesn't run, and the UTXO non-witness UTXO doesn't got deleted. So that's the code for checking whether we have any inputs or all the inputs which contains any SageWit or non-SageWit version of transactions or inputs. Okay, we will fast forward this in a little bit. Uh, so, what we are trying to do here, we are just sign our each input by passing this in a sign input function. So for each input, as you can see, for each vin, we are running this loop until the size of vin. So for each input, we are passing to the each input to this function, and we just make sure that all of the inputs are passed to this function because this function assigns various variables to them. For example, the signed PSBT input also assigns or initialize about the sighash type. and whether the signature is possible or not for a for a for a single input or not. So it's quite necessary for us to do this practice for all the inputs we have in the PSBT. So at final, we are just uh, passing all the inputs into this function, and we are checking if this function return uh, like an OK error or not. And then in this file of code, it's just a header file. So nothing interesting here. Like we are just changing the type of bool to this PSBT error. I already tell you about this optional and null field why we are doing this. And here also we are just changing default behavior to the null behavior because we'll just assign the right behavior according to the values passed in the PSBT or passed by the user explicitly in the commands or CLI. So that's all. Same thing. Some codes are seems to be repeated because the logic is written in many of the files. As you can see, all this logic is written. So let's see very quickly what this sign input does. Let's do this very quickly. Sign PSBT. Here is the function sign input. I hope it's visible.
Yeah, it's visible.
Yeah, so there are some arguments as you can see from here, like these, the like provider or PSBT or an index or transaction data or sighash type, which is optional, and then the finalize, which is also optional. As you can see here, these are all the arguments here. So we just after passing this, so PSBT just contains the information about the current PSBT you want to sign. So sign PSBT input only works for a single input, so not just you can't just pass the whole PSBT into this function and get a like a whole PSBT signed. You just need to pass a single input and just so we are checking if our past PSBT is already signed and already contains any signature. If the OK status like yeah, this is already signed. We don't need to do anything here. And just creating a variable to hold the signature data here. We are just initializing the signature data here from the given input and input here we will just initialize the input based on the PSBT provided in the arguments, and there is a check whether it is a whether it is require a witness signature or not, and then here we are just checking if the input belongs to a non-witness UTXO, means it's not a Segwit transaction. Then we are just do some checks. For example, we are checking if the previous output is greater than the input dot non-witness UTXO dot size, then we are returning the error like missing inputs. For example, if you contain less input than the desired, uh, then it will simply return the missing input error. And This just simply checks for the hash of your input. Like if the hash is not equals to the previous hash which your input are referencing to, then it's just also returning the same error, like missing inputs. And if all the things is correct, then we can just add this in our UTXO variable. Else, if it's not a witness UTXO, then we'll just add this UTXO directly without any checks here. Like the UTXO contains the witness UTXO fields, and we can also toggle the require witness signature to the true before it's assigned as false, as you can see here. Because if you are in this if check, that means uh, your input contains a witness UTXO, like it's a saturated input, and you just toggle this flag to true. As there's an error here, it's the same thing I just tell you before. We are if the sighash is not provided, and if it's a taproot input, we are just assigning it with the sighash default, and if it's not a taproot input, then we are assigning with the sighash all. So this line of code only runs when the sighash is not explicitly provided, or it doesn't contain anything about sighash. As you can see here, if the sighash flag is false, then this line of code runs. And yeah, and this condition is also important. For this conditions just simply tell if the sighash is provided in the PSBT, and if it's not matching with the explicit passed sighash, which you can provide through CLI, then this also returns the sighash mismatch error. Simply, we are just uh, checking the same thing here, like in the UTXO script up key, if it's a taproot, and if it's not a default, or if it's not for the tap, if this condition is true, then it just simply checks this condition, and if this is also not true, then this will set this sig hash here for the taproot or non-taproot. Later on, it just it just signed the input, a single input here. I'm not going to explain this logic. It's just clearly visible. It just calls this function produce signature and signs your input, and then finalized. If it's not finalized, then something uh, like this will uh, like change this flag to false. Like it's not the end of the PSBT. Maybe more inputs can come later on, and then afterwards we could toggle this to true. And then this line only run when we provided if we this this flag, this argument in our PSBT function, then only this line is run. Well, that's not useful for us right now. Okay, that's about the sign PSBT input function. And same, just need small things changing here. As you know, I'm not going to deep dive in here. We are just if uh, if if no sig hash provided, we are just assigning with the default one. And same here, we are passing the referencing variable here, not just the original or copied one. Same, the uh, the sig hash default is we are returning the null operator. This just checks if it's a taproot, if it's a taproot address or not, or if it's a taproot script or not. It's very easy. Like if its size is 34, or if its first first bit is OP1 and the second bit is 20, then it's a payroot address. All of the changes goes the same as before, just redundant code because the change is big. We need to rectify in most of the places. Same, calling the signPSBT function, and if the response is not okay or it's incomplete, we are returning that response. And same here, if it's the response is not true or if it's incomplete, we are returning the response. Same little bit things optional, null operator. And that's here we are just this for the fuzzing. We are initializing some new things in the fuzzing code. That's not worth, yeah, to mention. There's a little function, not a little function, that a little test written for this PR. We'll see the test in our Visual Studio Code. Not this one, I think. What is the name of this function? RPCPSBT. Okay, yeah, this one. So the test function just to do nothing, just create a wallet with the name sighash and get wallet RPC, call the wallet RPC for this wallet we have created, and then uh, there's another variable defined called define wallet, which calls same get wallet RPC, and then we are generating a new address here with of type bash 32, which is a taproot address. We are sending a 5 Bitcoin. So yeah, we are sending the 5 Bitcoin to this address, this new generated address. We are generating the blockchain of 6 nodes uh, on the node 0 here. And if the descriptors is true, if we pass the descriptors argument through CLI, and then it will just uh, fetch the descriptors and create a descriptor from a private key uh, using a wallet and the address we created before. This will create a PSBT. So this is the input is nothing. This is output. We are sending 1 Bitcoin, and we are creating this using this RPC call. The name of this RPC call is wallet create fund PSBT, and then we'll modify this created PSBT, and we are just adding this sighash all and sighash anyone can pay instead of this created PSBT, and then we just uh, like there is a decode change and then encode again here. Then we call we are checking if any one of these sighash can, if you pass any of these sighash through CLI uh, you in this PSBT, then we should get error. The error is this. The error code is 22 minus 22. So for for every call, we are just try like first passing the default one. Like in CLI, we pass default one. But as you know, we are already set the actual PSBT in the actual sighash in the PSBT is a sighash all and sighash anyone can pay. So if you pass through CLI and you say the actual one is default, but your PSBT says it's not default, is the sighash all or and this, that simply gives you an error. Like uh, if you remember, there is a line of code which I just mentioned, like that checks for the argument you provided through CLI, and if it's not match with the sighash you provided in the PSBT, that simply returns the error. So same, if you say it's of type all, but it's not, it's of type this. Same, you pass all the arguments here, and these are this simply returns the error here. If it's returning the error, that means our code is working fine. And afterwards, uh, and then we can check if after passing the all and anyone can pay, like this all and anyone can pay. If we pass this, then it's return equal, like complete, like it's true. Like the PSBT the sighash we mentioned in PSBT is this, and we are stating in our CLI through command or arguments, like this is the PSBT in this here. I think you can check by yourself. We are doing the things as described above, but we are do this with descriptors. We have done with wallets. We are now do this with descriptors. That's for the wallet and that's for the descriptor. From here also, like wallet, and if it's descriptors, we are generating a new address of which is of batch 32M, which is a taproot address. Generate a chain of blockchain of 6 nodes, 6 blocks, and then checking uh, like for the all and anyone can basic hash types, and then same here. If it's equal, then uh, they should return the equal flag here. And we are just finalizing the PSBT here because means that's the last input of the PSBT. And after finalizing the PSBT, we are going to do one more check. Same here, like we are changing the sighash type with sighash all, and we are checking if it's equal or not. If it's by the assert equal, if it's equal, then this assert should pass. After all of this, we are left with the right PSBT. We are sending this PSBT hex to the standard transactions RPC, and after this, we are generate a block here, one more block which consists of this transaction. After this, we are unloading the wallet here. That's all for this change. And let's move towards the question. Okay, questions. Questions are very easy. It's right. What is the concept of PSBT in Bitcoin?
The main gist of the concept is just like uh, how we would use uh, it's like how we would use uh, like a
Yeah, we
transaction
can. We like. Yeah,
like yeah like the
just
old
we can. Yeah, you
yeah
can. You can go.
oh sorry yeah so like the old version where you described in we are like we know that not all of the signers would be available online at the time of the signing which
Hmm.
is sometimes an issue, and this then eliminates the need for all the signers to be online at the particular time. We can just create a partially signed Bitcoin transaction at any time, then give it to all the signers that we would require them to. They can then sign them at their own time and whenever they require. And when all the PSBTs are completed with all the signees having been signed, we can then just like create a fully signed transaction and then broadcast it.
Yeah, perfect, perfect. That's what the meaning of PSBT is in Bitcoin. So, what is the purpose of sighash field in a PSBT and why it is important for multi-signature schemes? What is the purpose of the sighash field in the PSBT?
Like
So,
Sigash, yeah, Sigash just tells us
yeah,
type of transaction, what type of signature the transaction has. Sometimes they can
yeah,
have like all the inputs and outputs are signed by the same signer, or only the particular inputs and particular outputs are signed, or like
yeah,
particular inputs only are signed. Like this, it helps us to differentiate between these cases.
yeah. Absolutely. So, using the sighash, we can specify whether we want to commit to the all the inputs and outputs of the transaction or a single input, or whether like something else. So in PSBT, we just want to signal the PSBT, a PSBT creator updated that the previous the other members of the PSBT used the sighash type other than the default one. That's why we use this change to signal for the sighash. If it's not default, we will signal the change the sighash. So after this PR change, what will happen when we try to sign with other than default or all sighash?
Like for the default, it is just uh, we will remove the sig hash because it will be given by the user or the one that has created the PSBT.
Yeah, yeah, yeah. This is also like when we try to sign with other than default, all the first of all, the other users are notified. They can check like which signature we used to sign the our transactions. But if we did any inconsistency between stating our sighash in the PSBT while creating the PSBT or while parsing the PSBT while parsing the sighash explicitly through the CLI, then we can just uh, mm, got an error like you are doing something wrong. So how is SignPSBT input implemented and what checks does it perform? I think this is the same. This is this function. Uh, this function sign PSBT input. What this function do? You can see here for a little hint. Non-witness UTXO.
Yeah, just basic checks of if the inputs are correct, or if is any input missing, is the sig hash correctly applied, are the signatures correct
Mhm.
for the particular sig hash, and
Yeah.
the other checks if it is the right template.
Yeah. Yeah, so after checking all the checks like whether it is a part of a UTXO of type SegWit or non-SegWit, then it will act accordingly and this will just fetch few uh, like variables like this require a witness sig variable to false or true, whether on these conditions. And after this, it just sign the single input with this. PSB like the input of a PSBT. This will sign using the function. Using the function produce signature. After this, we just sign and return the PSBT. So this function signs for the single user. For example, like if you call we need to call this function for every user, for user one, for two, up to n. For user one also calls SignPSBT input, two also calls up to n also calls. We are just signing for each independent PSBTs, and at last we add them. So that's all for the today's peer review club. Thank you guys for joining in, and bye.